Hello everyone, it's Michaela here, and I have a question for you. What does this thing, and this thing all have in common? We're gonna use it to charge my phone without using electricity. Think that's impossible? Well, I hope you put some salt and spices on those words of yours, because you're gonna eat them. That was bad. That was a bad joke. Just start the video. Just start the intro. So, my partner and I are going to go camping this weekend. Super excited, super fun, except for the small fact that we both absolutely hate camping. Why are we going, you may ask? Well, it's the pandemic, so we can't really do anything besides existentially think about the end of the world. So, since there's literally nothing else to do in society right now, we figured it was a good time to go. Except, I love technology, and I don't like being without technology. So, my next thought was, is there a way I can build a cell phone charger that doesn't use electricity? The key is this little thing, right here. It's called a thermoelectric generator. These devices are insanely cheap. I got 2 of them for $8 at Amazon. I'll put the link in the description below. This takes advantage of a phenomenon in physics called the Peltier effect and the Seabeck effect. Let's head to the whiteboard and I can show you guys how this works in practice. So the thermoelectric generator takes advantage of what we know as the Seabeck effect. The Seabeck effect is the phenomenon where metals heated at the same temperature differential, as long as they're 2 different metals joined together, actually create an electric current once you apply that temperature differential. How does this work? Well, the 2 metals in question have different thermal conductivities. These different thermal conductivities are what allows charge carriers within the metals to be transferred at different rates and creates the voltage that we see. Okay, so here you can see I have connected my thermoelectric generator chip to a voltmeter. We're going to switch this to voltage, and this is going to measure how much voltage is getting generated from this chip right here. And we're gonna get the voltage by lighting this candle and placing it right on top of the candle. So let's get a light source. It's gonna smell wonderful too, because it's a scented candle. Okay, candle is lit. Now we're going to put this over the hot end of the candle, and in theory, you should see this go up because it's actually generating a voltage. Super fast response time too, wow. Ow, ow, that's hot, ow, ow. Okay, I'm just gonna use a wrench. That was very hot. I'll hold it over here. Going up, going up. Oh, there it goes, 0.9. See, the closer we get to the candle, the more voltage it actually produces. And as you notice, as we have this off to the side and the temperatures are equalizing, the voltage is going back down. Now, one interesting thing of this thermoelectric generator is that it doesn't matter how high the temperature is, it just matters how big the difference between the top and bottom sides of the chip are in their temperature. So it doesn't have to be super hot, but if we make the other side colder, that will also increase the voltage. Here we can take a standard cup and glue our chip to the bottom of it, right here. When we glue it to the bottom and fill this with water, what's going to happen is this is going to be a heat sink for the chip. So any heat that gets transferred from the bottom of this chip to the top is going to immediately shoot into the cup and into the water, and that heat transfer is going to keep the top of this chip at room temperature because the water is at room temperature. Only until all the water in the cup gets heated up is the top of this going to heat up significantly. If you guys watched my previous video, making my PCR reactor, you'll know that I use this thermal tape here as well. It's great because it's adhesive, but it also transfers heat extremely well and doesn't burn. Okay, we filled this cup with water now. It's still connected to the voltmeter. Now we're going to put the generator above the hot candle, and we're going to see how hot this gets now. Check out this voltage drop. Immediately we see an increase. I can actually put it closer now because the fire isn't as hot. 1.3 volts, right? So we can see that by using a heat sink, which is the water, over the candle, we actually get a higher voltage than if we would just have used the chip without the heat sink. Okay, so we saw how attaching a heat sink to the bottom of a cup with this chip was enough to get over 1 volt of power going out of the generator, which is great. The problem is that most chargers actually have power of 5 volts to charge the phone. So 1.1 volts or even 2 volts is not really going to cut it if we want to make any kind of reasonable charger. That is where this comes in. This is a voltage amplifier. It's a special circuit that has a USB attachment at the end that takes a voltage signal as long as it's over 0.9 volts and transfers that to 5 volts of signal. So we're going to take a fresh new Peltier generator, solder the positive and negative leads to this chip, and once we do that, we should, in theory, have a contraption that can output 5 volts of charge to any USB to phone adapter. I'm really excited for this. So let's set up my soldering iron and get to work. Oh, that was perfect. Hey everybody, so here I am in the woods. My partner is behind me chopping some wood. We had a really awesome night and we used a lot of our phone battery, so it's time to use our fire charger and get some juice back. I figured the best way to show this was, rather than filming my phone, which would be super small and unclear, I just decided to take a screen recording of my phone while in camera mode. So kind of convoluted, but here we can see the phone camera, and I'm lighting the candle and getting the experiment ready. With everything set up, the last thing to do is to plug the USB into my phone and then go to the home screen and check out the battery level. And as you can see in the upper left, we see the lightning bolt indicative of the charge symbol. Well, that actually turned out to be much easier than I thought. It only took me about 15 minutes to solder it together, and it actually charges our phone. If you like this video, give it a like, comment on how you would make it different, better, more powerful, stronger, faster, all that stuff. Share it with your friends, definitely subscribe. I'm gonna be making more stuff. I love making stuff, so definitely stay tuned. So yeah, this is Michaela signing off, and keep learning, keep building. I'll see you in the next video.